and also the main bank start from 1986 up to 2022. Okay, 2020, month 12. So for these two series, then I go to my e-news, then you can try to paste the data, e-news 13 or 12. So create a new work file, then it's a regular frequency, then it's monthly data in a monthly basis. Then you look at your series start from 1986 month 1. So 1986 month 1 up to 2012, right? Let's check again. 20. Okay, thank you. 2020 month 12. So it's 2020 month 12. And you go, okay, you're going to have a 420 observation. Okay. And what to do? You go to paste the data inside. You can go to create empty group any series and then try to paste the data here. So yeah, you paste it successfully. So what I need to do next is, once you have the data series, you also can get the same data set from a data top group, right? Then you have to generate the return series. So I use the difference in the log, okay, for this series, CIB and the Maybank. So this is the formula for me to generate my return series. So after you generate, the next activity is try to plot the log return. I would like to see whether there is a volatility clustering or not, right, for my plot. So you need to go to the generate the series. So try to tag the first difference here, right? Yes. So after you generate the return for the CIB bank, you also can generate the return for the Maybank, okay? Oh. And then go to generate series, right, for the main bank. So you're going to have the R CIB and also the R for the main bank series. You can try to plot them together to see their plot or their return plot. Open them as a group. You can go to view and then go to their graph. So you have a graph similar like this, right? So you're going to have a graph here, right? You have a Maybank graph and also the return for the Maybank and the return for the CIB. So once you have the plot, then can we estimate the cash for the Maybank and the CIB bank? For example, I want to generate the such series, right? So if I want to use these multivariate models, so as we discussed, we have 4 different, 1, 2, 3, 4, right? 4 different types of these various models, which are the classic models that are used in the past: BBCH, BKK, CCC, and BCC. So from this exercise, you will see their parameters is actually will reduce from the 9 to 7 and 7, right? 9 from the BKK, then when you, from this, then you reduce to 9, from 9, and then go to 21, go to 9, and then go to 7, okay? So let's see. Let's see, first one, the DBCH. We like to estimate the DBCH first, okay? So how to estimate? We can go to the, put them as a var form. So we brought these two together, then open them as the vector autoregressive estimation. So this one we want to, because this multivariate is estimate them in a system. So we use the vector autoregressive. Vector autoregressive means that we open as a system. That is a vector. It's a format vector. So we're going to have a 2 equation instead of 1. So this is called multivariate. We have a 2 equation instead of 1. So you can see your RCMP, you can see these are the 2 dependent variables. So for example, I just use the one leg for my dependent variables. So I have a 2 equation. One equation for the return for the main bank, another equation for the CIMP. So I'm going to have a 2 different equations, and then with their respective independent variable, which refer to the lag for the return for the main bank and the lag return for the CIMP. So you open them together, then we from here only start to estimate their variance models. So how we go to proceed there? So you go to open. So from this you can see the clustering, right? From the plot here you can see the clustering from the return here, right? So it means that the high return followed the high, and then low followed by low, right? This clustering, especially from the few several plot here, especially in 2000 here, right? So this is how we describe the graph from the return series. So if you want to proceed to this vector autoregressive, you open them as a var. You open them as a var, you just highlight the 2 series. You just use the control button, right? You use the mouse click on the RCMP, and then control, and then click another return for the main bank. Then open them as a var. So I start with a simple mean equation, 1, 1. So it means that I want to use the lag 1 for my dependent. It means that lag 1 for the dependent. So it's just lag 1 for dependent. Then other than that, you just put it as default. So I just want to estimate in their var at the lag 1. So I will generate the result just now. So I have the 2 vectors. If I have a 3 series, how? So you extend it and include another one more, right? So R return for CMP, return for the main bank, and if you want to include one more, return for the public bank, for example. So you're going to have a 3 different. So that's why it's a 3-variant case, like the case did by the minority. So now we only focus on 2. Then you go to estimate. You go to estimate. Sorry, not estimate. You go to prop, PROC. You go to prop. After you put in them as a var, you go to PROC. Then try to make system. Try to make system. Choose the make system button. Then order by variable, for example. Order by variables. Order by variables. So what's going to appear in your screen? If you go to, this is a main equation. If you go to order by variables, so this will appear in your as your main equation. So order by variable, put it as a system, order by variable. So we'll have this is your main equation, return for the main bank, return for the CIMP. So what you observe in your main equation, actually I can see whether the return for CIMP will going to affect the return for on the main bank, right? Not only by its own return, also by the return in other return from other asset, which is referred to CIP. So this from the main equation. It means that when I estimate the equation, I can base on this coefficient and their significant value to see their individual impact on the dependent, which is my return for the main bank. Right? So this also apply for the return for the CIP as well. Right? I can see the impact from the main bank on the return for the CIP. you mean I can see that their impact. This one step. This one step, right? This is not two steps, this one step, right? Also is from the own CMB Lackman period. -1, please refer to the Lackman period, means the previous month here. So okay, so it means that just now I open them, I repeat again now, open them as a while. So the leg here I choose one, then you choose OK. Right? Then you go to the prop here, then you choose the make system, order by variables. Then this is in the system. Right? Then what next? You go to estimate, you choose the estimate button. Then you scroll down the estimation method, choose the last one, arch. Because I want to estimate together with the arch, right? Variance equation, arch, which shows us the conditional heteroscedasticity. So once you click on the conditional heteroscedasticity arch, it will give you this arch model specification. Again, go to estimate, then estimation method, you choose the last one, arch conditional heteroscedasticity. So from here, you will appear the model we discussed, briefly discussed just now, which include the diagonal BEC first, CCC, and also BEKK. Then how about a dynamic? For a dynamic one, you have to install later, okay? You go to add in and install the dynamic one. So let us start with the diagonal BEC first. You click on diagonal BEC first. Then for in the various model, which are you going to estimate the use this model like diagonal BEC for the arch one or for the gash one, right? So these are the P and Q like we studied before, right? P and Q. Or you want to study about the threshold gash, right? If you want to study about the threshold gash, you put this one, you set into one, right? So this one is depends on what model you want to estimate, right? Beside the multivariate model here. So these are the multivariate. It depends on, it's a multivariate gash. Whether is it multivariate arch or multivariate gash one or multivariate T gash, right? Depends on your setting. Depends on your setting here. So I use the default one. I use the multivariate gash 1, 1. So my gash 1, 1 which include the arch term and also the gash term. Then other than that, I just use the default. Actually, there's a meaning here. For example, because this one is based on maximum likelihood, right? What are the methods, right, for your optimization? So these are the several things that you can go through if you're interested, right, in this field. So these are the settings here, which is discussed in the literature as well. So I use the default one. Then you here error distribution as applied in this univariate gash as well. So for this one, right, I'm based on a normal distribution. It's a multivariate normal. So for each series, I based on a normal distribution. Actually, if you scroll down, actually got the student T can apply to model the distribution instead of the normal distribution. So you can choose a student T, like the paper just now we discussed, right? The student T, remember, because of the normality issue. So I choose a normal one, okay? So this is a baseline, base. Then you click OK. Remember, this one is based on the iteration. If you set more iteration, this is based on a minimum 500 iteration. It means that when to converge is depends on 0.0001. So the result might be different if you set iteration 1,000, right? Sometimes 5,000. And then you can see some research paper, they say, okay, my iteration or my replication is based on 100. 100 is too little. Right, 500, 1,000, 5,000. So the more iteration you put in, the more time you are going to consume longer time for you to come up with the final result. But it's more accurate, right? More accurate. So this one is called as an iteration. And it's okay. So it's loading. Okay. So it's converged, achieved after only 67 iteration here. So this is my result. So that's why you found what is C1 up to C6, right? These are the mean equation. C1 up to C6 refer to the coefficient for your mean equation, and these are the coefficient for your variance equation. So for how many? 2, 4, 6, 8, 9, right? 9 parameter from this diagonal. It start from 9. So if you go to, then I want to see which one refer to which one. If you want to look at their details, you can go to the system specification here. Oh no, sorry, not system. Representation. Actually, it's a representation. If you open up their representation, it's actually referred to the work file I shared just now. Right, I shared here. It's a diagonal, you see here. These are the open as the representation. Remember, after you estimate, go to view, representation. So these are the representation, actually refer to the work file here. Yeah, work file here. Maybe make it simple because different iteration have a different result, right? So I'm going to have but not much different. I'm going to discuss this one. So you copy the representation here, then okay, I just want to do this one now, okay? So this is my model. So my estimated equation, which refer to my mean equation. So my mean equation here, that's why is C1 up to C6. So C1 is a lag for the return for the CMB. So C3 and C6 is referred to the constant. So if you go back to look at the output, so what is C then? C3 and C6. So this C3 and this C6, these two actually refer to the constant. Right? C3 and C6 refer to the constant. So this refer to the constant. This is how we read the coefficient. So if they plug in plug in the coefficient inside, right? So these are when they plug in the coefficient, right? Plug in the coefficient. This refers to the mean model, right? Mean equation. Then for the variance, covariance representation, right? Yeah, this one. A1. A1 refers to the variance, what we say the correlation. The correlation for this is a gauge, right? Correlation here. So now, how to look at their individual gauge model? Individual gauge model is this one. M11 and M12 refer to the constant for this variance equation. So where is M11 and M12 here? When you scroll down to the last page, right? Last page, the bottom part. This is the M11 and M12. This refers to the constant for this model, constant. It's called M11, right? M11. And M22. M12 actually refers to this, to the covariance equation. So that is the way we want to know actually which coefficient EV is provided to us. And this one is the gauge and arch term, right? Gauge and arch term for the respective variance equation, A122 and B122 as well. Okay. So this is how we read the thing. Then if you want to know the details, right, for this something like the covariance, right? So this is the M12, A112, B112, all this. M12, right? And then we also have this A112 and also the B112. That's referred to the covariance equation. Covariance equation. So this is the representation. Then actually, what we concern here is this one. A112 and also the B112. You want to see their impact, right? Their impact on whether significant or not significant, what we say this correlation. So now we highlight this one, right? Yes. A112 and B112. So here, A112 significant? Yes. Highly significant, right? A112 and also the B112 with a 0.867. So these are the information you can get from this multivariate diagonal VCH, right? Diagonal VCH. So now, what else I can produce, right? I can estimate. Actually, if you want to estimate another model, you can click on it, then you can see the diagonal BEKK. By the way, you can summarize first, right? You can summarize the result. For example, you can summarize the result as follows. So these are the diagonal, right? Diagonal VCH, you can summarize them. For example, I just copy and paste my EVs, right? I come out with this result, right? This is my result. So for how many parameter estimate here? 9, right? 9. So 9, right? Then the parameter estimate, then you can reduce to 7 if you estimate based on the BEKK. Then the parameter estimate also 7 if you based on the CCC. But the difference is what? The difference is, so now we discussed about the advantage, right? The BEKK and the CCC, right? So now the important point for this chapter is the difference between multivariate and also the univariate. And also why we want to something like, for example, what's the difference between the diagonal VCH together with the BEKK, right? So as you can see, this one is here, right? So what are missing? What are the two missing parts here? Can you spot it out? Can you spot it out or not? A112, right? Yes. A112 and B112 is cannot be you cannot see in the BEKK model, right? So this is the difference compared to the DVCH in the BEKK. So let's see how's the BEKK work. By the way, you can try to view their graph also, right? Before we go to the BEKK. So what we can do with this one, you can look at the conditional covariance. Just want to ask you, can we estimate the unconditional one? Cannot. Unconditional one is actually well behaved, right? So we are not interested to look at the unconditional. So what we interested is look at the conditional, which we can model by using this Gash family. So if you want to look at their conditional covariance, like what we say the models like the plot, right? So you can go to the conditional covariance, right? The graph, the display. You can display their correlation. You can display their covariance, right? Let's say I display their correlation. So you can look at the graph. So you can try to say, okay, yeah, this is a conditional correlation. It's a time varying, right? Time varying also. For this conditional correlation for these two series, right? For these two. Yeah, you can see their correlation actually is it increasing or decreasing, right? Correlation actually is increasing somewhere here, but now decreasing a bit, then suddenly go up a bit. But it's still not that it's still below 1, right? Actually the correlation is 1. Is below 1 here, right? Still below 0.8, sometimes at 0.8. So how about their conditional correlation, right? So you can go to their graph, for example, conditional covariance, like the variance, for example. Variance, right? And look at the graph. So this is the variance, right? These are the something like the plot, right? I copy the clipboard, for example. I want to look at the details here. Yes. Oops. Yes, this one. So their variance, right? Their variance is it any different between these two series, between these two company? So CIB Bank actually is quite what we say high fluctuated, right? Especially in the year 2000, right? Maybe it's because of the Asian financial crisis, right? Early year 2000. Actually it's between late 1990 up to early 2000, right? Somewhere around here. I think it's somewhere related to the Asian financial crisis. So the return series actually is increased a lot in the late 2000, in the late 1990, as compared to the global financial crisis, which happened in the late 2000. Right? Late 2000, 2007, 2008, right? Little bit, right? So the impact, right, on this Asian financial crisis, for example, has a very high impact as compared to the global financial crisis. As well as the COVID-19, right, also is a not that increase the volatility for the return, especially for CIMB Bank and also the bank. But the impact is quite high, especially during the Asian financial crisis. But as compared to the CIMB, the volatility for this Maybank also quite volatile, right? Quite volatile. But maybe because I brought them with a different skill, right? Because here it start with 100, but here it start with 200. So if you put them together, you can compare much more precise, right? Be careful the skill as well, right? Be careful the skill, okay. So now, what else I can observe? I also can observe study what we say the core variance as well, right? Core variance. So these are the core variance together. So not only variance together with their core variance for this conditional variance. So okay, so now what else I can estimate? You also can go to estimate different type of model. For example, the CCC. So CCC, Gashman 1, then you say, okay. So here, 7, right? 7 parameter. You want to see actually what is N1 want to measure about, right? What is N1, N2? You can go to the representation. Again, if you open them here, I see here CCC, yeah. So CCC again as with the mean equation, and then together with the variance equation. So this variance equation, you're going to have two, right? Because I have two return series. So I have a C set, have a 2 series. So I have a different equation, Ash and Gash term here. So the core variance here is a square root, right? Square root for the Gash from your first return receipt together with the second return series. So what people concerned about is the this coefficient, right? The rule, right? The rule we discussed just now, the rule there, right? The rule. You also can try to plot as well. You can see they are different, like the Monivik paper, right? You see the Minowick, sorry, it's a Minowick, yeah? See, yeah, core variance, right? The core variance and also the what we say, the conditional core variance as well, right? So now, how about go to their graph? For example, to look at the correlation graph, like this. It's a different, right? It's a different, that is true. Then, how about their, this is a coefficient covariance. So how about their variance? So, like this. So almost same, right? Yeah, almost same. Almost same, the CCC, right? So now, how about the BEKK? If you go to the diagonal BEKK, then you can, okay. Oh, how come like this? Just now I still can estimate. Maybe I start over again. Still same. What you forget? Is it not available as well? Oh, same like this. Okay. Well. This might be BEKK result. I run previously. So, I don't know why. But I using English chapter, maybe, I don't know. One singular core variance are not unique. Why? Well. Let me think for that. By the way, this is my BEKK. Perhaps you can, So let me try. I think I tried this one previously. It's workable. So this is BEKK. Let me, before we diagnose, right? So BEKK, then this is my estimate equation. So the thing here is same like we discussed previously. So, but the difference is, what is the difference? The difference is you still can see the Ash term, Gash term, but I think it's because of this constant, right? Constant for each variance equation. And also you can look at their core variance as well from these two Gash variance series. It means from the Gash series, you can look at their covariance, because this covariance include the residual from the first gush model, it means from the first mean model, and also the residual from the second return mean model. So right, that's why it's important information, especially this covariance, right, 0.85. So now, what other information? Yeah, when you estimate the BEKK, right, your parameter becomes 7 as compared to the previous one of 9. Right, previous one you have 9. So that is the extra information. It's proven the Minovic, what we say a claim, right? You will have a lesser parameter estimate if you base on the BEKK as compared to the DEBC. Similar as CCC, you're also going to have a 7 parameter estimate. So that is the information you can obtain, especially on their covariance, like this one 0.62, 5 is this one is 0.85. Is additional information, especially on their covariance. So now, how about what we say another one, the dynamic one. The dynamic, right, is additional. You have to go into add in. Then you have to click this manage add in. Add in, right? You have a button here, add in. Then you have to click the manage add in. You have to click on this available here. Again, you go to add in, manage add in. Choose the second one, or choose the first one just now, because I already downloaded, right? Choose the manage add in. Then choose the available button. Then here you look for the diagonal, look for the D, right? Yeah, this one, DCC Gush 11. DCC Gush 11. Because this one is an additional package for people who like to have an additional estimation, right? So you can install here, for example, you scroll down, there are a lot of the other package for you to install beside the standard package. Then for this DCC Gush 11, right, you just click install. So click install, it will help you to install the DCC Gush 11. Okay. So you click install, then you click OK. Then you will see, you will appear in the add-in button here. When you click add-in again, you will appear in the top dynamic conditional correlation 2-step. It means you will estimate the Gush model first, after that only study their correlation. So once you click on it, you will see here, DCC Gush 11. Either you choose either you estimate which type of Gush model, whether you estimate the standard Gush or threshold Gush or the E-Gush, right? Then you put in, for example, I estimate the Gush. I ask the EViews to help me to estimate the E-Gush first, or you want to estimate the Gush. I want to standardize with others, right? Estimate with the Gush. Then for the return series, you just type in this one. We only have 2, right? 2 return series. So the RMAN bank and RCMB, right? RMAN bank, RCMB, and also the RMAN bank. You also can put in the exogenous variable in the main equation, if you want, okay? If you want to study the others exogenous on your return for the CMB or your return on the main bank, you can put inside here. If you want to put other variable in a variance equation, you can put inside, put in this, box here, okay? So if I estimate the Gush, and then here is use the default, right? 1, and you want to use the error distribution, either it's normal or student T, right? So you can choose the normal, as I want to start with normal, because I haven't tested for normality, right? So I start with the normal. Then other than that, I just use a 5,000 iteration. Sorry, it's 500. If 5,000, maybe take 1 day, should assume 500 iteration. Then you click OK. Okay, this one is written by this author. You click OK. Then you will see different equation will appear. You will see here. They will estimate you here. Equation Gush 11. So what are the advantages for you to use this multivariate Gush based on this dynamic Gush 11? Actually, you can just put in the return, right, for several or for a group and help you to come up with the a group of the Gash equation, right? So you can see equation for Gash for the first series and equation for the Gash for the second series. Last time you just key one by one, right? Estimate one by one, but now you can estimate in a group. If you want to look at a very huge many return series, right, you can use this one to help you to set the time, for example. But what we're interested in on this dynamic, right? Dynamic. So, how to see it? How come perhaps we can use the what we say the previous chart, right, to better have a better looking. Right. This one is their dynamic, right? This one is the constant, and also this one is to the arch. Their correlation, right? But how come not available here? Don't know. Well. So stability condition, these are the arch and Gash, right, have to be less than 1 in order to be stationary, right, as we discussed in the previous means in the second half of the lecture. So that is the dynamic Gash, dynamic Gash. Actually, you can go through, because of the time limit, right, you can go through this multivariate Gash, right. It's the link, it's a video, right, for you to take a look at, right. Yeah, it's not asking you to use their what we say their what, you can go through their explanation. Okay, you click on the link here, you can go through the explanation. So these are the things you can study. Like this, you can see their various equation for the main bank, right? Yeah, and these two are significant, and this is the mean equation. So actually, you can try to add in also, add in, right? For example, you want to add in dynamic. For example, you want to put the exogenous variable in the mean, you can try to put the lag. Because in the mean equation, it's just a constant only. You see? There's a constant here, right? Perhaps you can add in the variables like the lag for the main bank. Right? Here you put the return for the main bank, right? Return for the main bank, and then return for the CNB, right? CNB. Then here you can put in the lag. Exogenous, right, you can put in at the lag now. The lag for the main bank and then the lag for the CNB. To match back up to estimate the AR1 models, right? Yeah, something like that. Then you try to estimate, see what happens. See, are you going to have a yeah. So I'm going to have this, right? Still not available. Maybe some of you maybe spend some time, right, to adjust something, maybe come out with available information, right? By the way, so this is how we something like apply this multivariate Gash to provide you extra information, right? So this one is my Gash. Yeah, it have this. So you can see the return, right? The return for CNB, what is the impact on the return for the main bank is positive, right? Positively. So it means that there is a return, is a positively on the return for the main bank. It's a positive impact, right? So if you want to put in the other variable in the variance equation, you can try to put inside. We have to see whether other information is going to impact the variance. Okay, that's only, right? I just want to have some introduction, just a little bit introduction on this, what we say, the multivariate Gash. So, okay, let's go through something like the recent development, right? So, still remember the invited lecture by the Professor Teo, right? Professor Teo, right? Talking about the AI.